So, welcome students. Today we will see about the derivatives of naphthalenes under the polyaromatic hydrocarbon chapter. So, derivative of naphthalene meaning is naphthalene having some functional group, right? For example, like nitro group, hydroxy group. So, like that, and how they that can be synthesized, prepared, and what are the reactions of this derivatives, naphthalene derivatives, and their uses. So, let's see. What are the derivatives of naphthalene we are going to see under this in this chapter. So, important derivatives of naphthalenes are there, of course, the nitronaphthalines, which is having a nitro group, nitro functional groups attached on the naphthalene ring system. So, this is a nitronaphthalene. This is one nitronaphthalene because its position is 1. This is one or alpha position. This alpha position or 1 position, this is beta position or second position. So, this 1 represent this position. Similarly, we can also get the naphthalene derivative as in the second position, this nitronaphthalene, and this or beta nitronaphthalene. This is the second position. This is the structure of the beta naphthalene. So, you can see the nitro group is attached here in the first position, and in this case of beta nitronaphthalene or 2 nitronaphthalene, this nitro group is attached in the second position. Another very important derivative of naphthalene is alpha naphthol. Alpha naphthol, where the position of the hydroxy group, this hydroxy group is attached. So, OL naphthol, OL meaning is alcohol, right? So, this OH group is attached in the first position or alpha position. So, alpha naphthol I designated as alpha naphthol. Similar to the nitro group and the 2 nitronaphthalene, if the hydroxy group is attached in the second position or in the beta position is called beta naphthol. So, these are the 4 important derivatives of naphthalene we are going to see in this class today. So, now let us give focus on this alpha and beta nitronaphthalene. So, synthesis of nitronaphthalene. So, this is the alpha nitronaphthalene and this is a beta nitronaphthalene, also called as 1 nitronaphthalene or 2 nitronaphthalene. Their structures. So, how it can be synthesized, how it can be prepared, right? So, first is the synthesis of 1 nitronaphthalene. So, this can be prepared by direct method. So, what is the meaning of direct method is we can directly prepare this derivative, this nitronaphthalene derivative starting from naphthalene. So, here is the scheme, reaction scheme, where this is a naphthalene ring system is represented here, and if we add some nitric acid, concentrated nitric acid, which is called as nitrating agent, right, because this NO2 plus electrophile is coming from the from the nitric acid. We also need some drops of sulfuric acid as a catalyst. So, we also add some sulfuric acid, concentrated sulfuric acid, and we will get the nitronaphthalene, 1 nitronaphthalene. So, this is how we can prepare 1 nitronaphthalene by taking naphthalene and nitrating agent, that is nitric acid in the presence of some acid. So, importantly the sulfuric acid. So, we get this product, and this is the direct method. What about the indirect method? Indirect method, we can prepare 2 nitronaphthalene. The direct method we can prepare the 1 nitronaphthalene, and indirect method we can prepare 2 nitronaphthalene. So, this is a scheme when 2 amino naphthalene, so this is a 2 amino naphthalene, right. Indirect method meaning is if you have already having a functional group attached on the naphthalene and you convert to some other compound, in this case naphthalene to nitronaphthalene, right. So, you have to convert from amino to nitro group. So, this is called as indirect method. So, if you start from 1 amino naphthalene, that this one, and if you add some sodium nitrate NaNO2, what you will get is this product in the presence of some acid. Here I have added some HBF4. Okay, why I have added HBF4? Why not other acid? Because this BF4 is a good counter ion. BF4 is a non-coordinating counter ion. So, I use this one. If you use HCl, HCl will bind somewhere. So, this will not bind, this will stay outside, make it neutral. The charge should be always neutral. We all know that in chemistry that if you prepare a compound to be stable, it should have a neutral charge. So, I use this BF4 as the counter ion, right. So, what you will get is naphthalene to diazonium tetrafluoroborate. So this is naphthalene and this is diazo. Diasa means nitrogen, right? This di means 2, so 2 nitrogens are there. So diazo compound is having a tetrafluoroborate as the counterion, BF4 as the counterion. This is the complex. So in the indirect method, we first prepare some intermediate, that is this one, and then you add something and get the product. So what we added is copper nitrate. Okay. So we get this product. This is the step 1, and then add the copper nitrate. Copper nitrate will remove the N2 nitrogen, okay, and we attach the NO2 here. NO2 will go and attach here. So we will get this 1-nitronaphthalene as the product. This is the indirect method to prepare the naphthalene or beta nitronaphthalene. So we have seen 2 methods to prepare 1-nitronaphthalene and 2-nitronaphthalene, right? So let us see about the uses, how these nitronaphthalines, 1-nitro and 2-nitronaphthalines are useful in the real world. So they are useful as important as intermediate and used in the nitronaphthalines as an intermediate used in different products, right? First one is dyes. So they are give very nice colors. Okay, so if you change, if you put the nitro group, it will give a very nice color, and this 1-nitro and 2-nitro we used as dyes. Like this kind of different colors you can get by attaching different substitution. Okay, if you add some hydroxy nitronaphthalene, chloronitronaphthalene, it will give different colors. So it is used as a dyes. So nitronaphthalene intermediates means starting as intermediate is used in dyes, in rubber chemicals, and also in pesticide. You can see here this person is having a pesticide and is using this pesticide for to protect his crops, right? So this nitronaphthalene intermediates are used to prepare pesticides. So these are the important some of the important uses of 1 and 2 nitronaphthalines. With this we will move on to see the next derivatives of naphthalene, that is naphthols. Naphthol, OL is having the name, it is having a OL meaning alcohol, right? It is having OL, anything with an OL, it is an alcohol. So you can easily find out what it is having. So naphthalene with alcohol, right? This is alcohol group, OH group. You can see in the structure in the naphthol, 1-naphthol or alpha naphthol, it is having hydroxy group at the first position. And in the case of this 2-naphthol, it is having an hydroxy group in the second position. So these are the 2 types of derivative of naphthols, of naphthalene. So now let us see in more detail about the naphthol. So monohydroxy naphthalines are called naphthals, right? This is having 1 hydroxy group. They are called as naphthol. Not 2 hydroxy is not called as group naphthol. It is having structure naphthalene having only 1 hydroxy group should called as naphthals. So this is 1 naphthol and this is 2 naphthol. The structures are shown here. And where it occur in nature? In nature we can get this naphthals from the coal tar. So if you have a coal and if you process, and the coals are mainly used in India for the electricity. So 80% of electricity in India is coming from coal, right? Coal mining and coal burning. So after in this byproduct you can get is naphthals. So this is a occurrence, how it occurs naturally, how we can get naturally. We can also prepare the naphthol from synthesis like in lab. This is very important because we cannot depend on the nature for getting this important chemicals. We have to prepare it in the lab for large scale synthesis, large scale preparations, right? So let us see how to prepare these 2 chemicals in 2 compounds in laboratory. So synthesis of naphthol from the laboratory, right? This is the synthetic scheme for preparation of naphthol from the lab. This is the synthesis of alpha naphthol or 1-naphthol. So how to prepare this naphthol? See, this is a product here. I have shown this is a product, and we can go back side how to prepare this. This can be obtained from naphthalene to sulfonic acid, right? This is the one step before preparation of this one. And how we can get this once naphthalene 1 sulfonic acid. This is 1 sulfonic acid. We can start from the naphthalene, right? So naphthalene reacts with sulfuric acid. Naphthalene reacts with sulfuric acid at 40 degree to make this naphthalene 1 sulfonic acid. Okay, this is the naphthalene 1, not 2. This is a naphthalene 1 sulfonic acid. This one. And if you take the naphthalene 1 sulfonic acid, if you add some sodium hydroxide, it is a base, it will immediately cleave this bond. Okay, and then the OH group will attach here. So, it is a very easy reaction if you take with base. So, acid base reaction here going on here, and to get the beta naphthol, that's alpha naphthol or 1 naphthol. This one, this is not beta naphthol, this is 1 naphthol. So, this is how you make the naphthol from the starting from naphthalene, converting to an acid, preferably sulfonic acid, like naphthalene 1 sulfonic acid, and then add base and then drive the reaction to get the product. So, this is how we can prepare 1 naphthol. Now, let us see how to prepare the 2 naphthol. This is beta naphthol. So, you can see that here the naphthalene comes in the beta position, the second position. Same reaction we can use, but only thing is the change in the degree Celsius. Okay. You can see here, if we prepare this 1 naphthalene 1 sulfonic acid, we need only 40 degrees Celsius previously to prepare alpha naphthol. But in the case of preparation of this beta naphthol, right, this OH group is here, we need to first prepare, take the naphthalene and add nitric acid, sulfuric acid, okay, this is sulfuric acid, and then heat to 180, not 40 in this case, is 180 degrees Celsius to get the naphthalene 2 sulfonic acid as the product. And then you take some sodium hydroxide and heat it at 300 degrees Celsius to get the beta naphthol. So, how to prepare the beta naphthol? You take the naphthalene, add sulfuric acid at high temperature, because high temperature is needed, because we have to, normally it has to go here, right, it has to sulfuric this SO3H will go in the, prefer to go in this position, but if you heat it, it will drive to go to this position, second position, and then finally you can add the base to get the product. So, this is how we can prepare 1 and 2 naphthol from starting from naphthalene. Now, let us see some of the 2 important reactions of alpha and beta naphthols. So, reactions of alpha naphthol, this is alpha naphthol. If you take the alpha naphthol and added HNO2, okay, HNO2, you will get nitro group attached here. So, this is an important reaction to get the nitroso compound. This is 2 nitroso 1 naphthol, this is one. So, naphthalene reacts with HNO2 to give 2 nitroso 1 naphthol, this one, which undergo tautomerism, okay, means the double bond can shift. See, the double bond goes here, and there is a bond, hydrogen bonding forming between the oxygen and the hydrogen as shown here, and also this double bond also can shift to the nitrogen. So, this is how you can prepare the naphthoquinone 2 oxime. This is an oxime derivative, and this is stable because it is 6 membered. You can see with the hydrogen bonding, there is a not clear bond here, just an imaginary attraction between the hydrogen and oxygen. But you can see there is a 6 membered ring is forming, 1, 2, 3, 4, 5, 6. 6 membered are always stable, so it forms a stable oxime, naphthoquinone 2 oxime. This is one of the important reactions of naphthols, alpha naphthol. So, if you take an alpha naphthol with HNO2, you will prepare the nitroso compound, right. So, nitroso compound is very important in medical field, because it acts as a messenger, right. It can is a neurotransmitter also. So, this is nitric acid and so NO compound. So, this is a nitroso compound NO. So, you can prepare this one, and then you can prepare easily, it can rearrange to form the oxime, this stable structure. This is naphthoquinone 1, 2 oxime. This is one of the very important reactions of alpha naphthol. The other reaction we would like to see is the reactions of beta naphthol. So, beta naphthol, as already mentioned, it's and the OH group is present in the first position, right. This is 1, this is second position, this alpha beta, the hydroxy group is here, this beta naphthol. And if you add some NH3 group and ammonia, what you will do is, ammonia replaces this hydrogen, oxygen and hydrogen, and it forms, water will remove and then NH2 will attach, right. So, you will get this beta naphthylamine. This is also a very important commercial product to make different drugs and chemicals. So, this beta naphthylamine. So, we can prepare from beta naphthol. So, these are the important reactions of beta naphthols. One of the very important reactions of beta naphthol to get the beta naphthylamine. So, also this beta naphthols are used as dyes also. The uses of beta naphthol, alpha and beta naphthol can be used as dye, because you can see the naphthalene is having this 2 aromatic rings. So, it gives nice color if we put some functional group like OH group, nitro group and all. So, this can of easily useful to make dyes. So, these intermediates and other things are used for making dyes. So, this is the two important reactions of alpha and beta naphthol. One is to get the beta naphthalamine, and the other one is to make the nitroso compound, and then which rearranges to form the oxime. So this is the two important derivatives of naphthalene. One is the nitronaphthalene, it is having two types, right, alpha and beta nitronaphthalene, and similarly this naphthols is having two types again, it is alpha naphthol and beta naphthol. So in the next class we will see about anthracene. Anthracene is not having is having three aromatic groups attached, right, naphthalene and phenanthrene, and we will see, and we will finish this polynuclear hydrocarbons, right. So this is all for today's class, and I will see you in the next class regarding we will discuss about the anthracene and phenanthrene. Thank you.